All right, let's talk about the power of it depends, because we're about to dive into one of the most crucial concepts in all of data analysis, understanding interaction effects. And a very warm welcome to the Tao Salon of statistics. This is the place where we don't just crunch numbers, right? We're here to really listen and understand the elegant stories that our data is trying to tell us.
So, think about it. You run a huge study, you launch a new product, maybe you're testing a new drug. The number one question is always, did it work? And look, getting a simple yes or no would be great. It feels so satisfying. But honestly, the most insightful, the most powerful answer you can get is often, well, it depends. And digging into what it depends on, that's where the real magic is. So here's what we've got on tap. We're going to look at what happens when lines on a graph just don't align. Then we'll break down the two major types of interactions, ordinal and disordinal. After that, we'll get into why ignoring these can be so dangerous, and we'll wrap it all up with 3 solid takeaways for your business.
Okay, let's dive right in. We're stepping beyond that simple, one variable at a time mindset. Because the real world, it's messy, it's complex, and to really get it, we have to uncover the hidden power of combined effects.
So, what exactly is an interaction effect? Well, put simply, it's when the impact of one thing, let's say a new marketing campaign, isn't the same for everybody. Its success actually depends on another factor, like, whether a customer is brand new or a long-time loyal fan. It's all about seeing how different variables play together. To make this really hit home, let's grab the example from our source material. Imagine we're testing a new medical treatment. An interaction effect here would mean that the success of this treatment isn't just one simple number. Now, it might work really well for females, but maybe not so well for males. See? The effect of the treatment depends on the patient's gender. Okay, the absolute best way to get your head around this is visually. So let's forget about all the complex formulas for a minute. This is all about looking at the shape of our data.
Let's start with the easy one. If we plot our results on a graph and the lines for our different groups are perfectly parallel, boom, that means there's no interaction. The treatment has the same basic effect on everyone. It's consistent. Nice, simple, straightforward.
But where things get really interesting is when the opposite happens, when those lines are not parallel, when they start to diverge or converge. That is your giant visual clue. It's literally the data screaming at you, hey, pay attention, something more complex is going on here. The effect is not the same for everyone.
Right, but even then, not all interactions are created equal. We've got to break it down into 2 main types, because they tell completely different stories. One is just a matter of degree, but the other is a total reversal.
First up, we have what's called an ordinal interaction. Take a look at this graph. You can see the lines aren't parallel, sure, but, and this is key, they don't cross. This tells us the treatment works for both groups, but it's more effective for females. So the big takeaway here is that the effect is going in the same positive direction for everybody. It's just a matter of how much. And that brings us to the second type, the disordinal interaction. And whoa, look at this. See how the lines actually cross over? This is a huge, massive red flag. It means the treatment might have a positive effect for females, but for males, it's either totally flat or maybe even has a negative effect. The impact doesn't just change in strength, it can completely reverse for another group. This, my friends, is an absolute game changer.
So why are we making such a big deal about these crossing lines? Because if you're not looking for them, you can be so dangerously misled by just looking at the simple average. Let me show you exactly what I mean.
The source material just nails it with this quote. It says, when interaction effects are present, interpreting the main effects is incomplete or misleading. It's like you think you know how the story ends, but you've completely missed the shocking plot twist in the middle.
And here it is. This is the big aha moment. On the right, you see a simple bar chart. It's the average effect. And hey, it looks like the treatment group did better than the control group. Great, we have a success, right? Nope, dead wrong. Because the chart on the left tells the real story. That nice, clean average on the right is completely hiding the fact that all of the benefit came from the females, while for males, there was basically no effect at all. Imagine the terrible decision you'd make if you only saw that bar chart on the right.
Okay, so you've done the good work. You've found an interaction. You've dodged the bullet of the misleading average. Now what? What's the next step? How do you actually dig in and investigate it properly?
Think of it like this, a quick guide for the data detective in you.
Step 1, you find a statistically significant interaction. Step 2, and this is crucial, you stop. Just pause. Don't even look at the main effects, the overall averages. Instead, you move to step 3. You use what are called simple effects tests to explore what's going on. And that lets you get to step 4. You can finally pinpoint exactly where the real differences are. You're shifting your question from does it work to the much smarter question, for whom does it work and how?
All right, let's bring this out of the stats world and into the real world. Let's talk business. Here are 3 really critical takeaways you can use to make much smarter decisions with your own data.
Takeaway number 1, always look for these combined effects. So don't just ask, hey, did our new marketing campaign work? Ask, did it work differently for our brand new customers compared to our die-hard loyal fans? Because a message that's amazing at bringing in new people might actually tick off your core audience. That is a classic interaction, and you absolutely cannot afford to miss that. Number 2, that crossing lines graph, I want that to become your new favorite red flag. When you see that in your data, your alarm bells should be ringing. It could mean that a new app feature you just launched is an absolute home run for your power users, but it's so confusing and annoying for casual users that they're leaving in droves. A positive result on average could be hiding a complete disaster for a huge chunk of your user base.
And that leads us to takeaway number 3, which might be the most important one of all. Averages can be dangerously, catastrophically misleading. An average bump in sales or user satisfaction feels like a win, right? But what if that average is hiding a massive drop-off from a small but incredibly profitable group of your best customers? You could be celebrating a victory while you're actually sinking the ship. You'd be making a terrible decision based on incomplete data.
So from now on, the next time someone shows you a simple average, a single number, I want you to be the one in the room who asks, okay, but what does the interaction look like? Because the most powerful stories in your data, in your business, in your research, they're almost never about the average. They're about digging in and understanding why the true answer is, and almost always will be, it depends. So I'll leave you with this. What hidden interactions might be shaping your world?